Okay, matter isn't mostly empty space. That should be obvious. I'm sitting on a chair and I'm not falling through the chair down to the first floor of my apartment building. And unless I am Kitty Pryde or The Vision or Barry Allen or Wally West, I'm not going to be able to do that. Okay. So why do people say that matter is mostly empty space? It dates back to when Ernst Rutherford fired alpha particles at a gold foil, and he expected the alpha particles to be deflected by the gold foil. He did not expect alpha particles to bounce to hit something and bounce back. What Ernst Rutherford did was discover the nucleus. So people said that atoms consist of the nucleus is at the center, and most of the atom is empty space, and therefore matter itself is mostly empty space. But while it's true that atoms do have nuclei and they're very small and massive, they also have electrons, and the electrons occupy orbitals. So what is an orbital, and what do we mean when we say that electrons occupy them? Let me explain about wave-particle duality. Electrons and atoms behave like waves. If you give an electron an atom its ionization energy, then the atom becomes a positive ion and the electron becomes a free particle. Electrons and atoms behave like waves, but electrons behave like free particles when they're outside of atoms. So we can think of electrons as atoms in particles, even though they behave like waves. What do I mean by that? Well, look at covalent bonds. Electrons are actually shared by atoms and molecules, and this is what creates the bonds. So there are two ways to think about electrons and orbitals. It is an electron. If an electron is a particle, then an orbital represents where you have found the electron in the atom. But there's an uncertainty regarding its location. Okay. According to Heisenberg uncertainty, this uncertainty regarding the particle's momentum is high when you know where the particle is. Okay, so by observing the electron, you are probably ionizing the atom and cause the electron to fly free of the atom. On the other hand, what if the electron is a wave? Well, then the electron pair consists of up and down spin electrons, and they occupy the entire orbital. This is what the electron behaves like when you aren't looking at it. Hence the Schrodinger's cat analogy. But wait, there's more. Only two electrons can occupy the same orbital. This is the Pauli exclusion principle, which is a special case of Fermi-Dirac statistics. Fermions are particles with half integer spin. And if you try to have fermions occupy the same space, then there is a quantum pressure keeping them apart. Ultimately, this is why I'm not falling through the chair right now. Thank you for listening.